Karthik is from SIONIC Energy in Rochester, New York, and speaks about silicon anode technology with drop-in capability. The floor is yours, Karthik. Many thanks for making it.
Thank you very much. Are we good now? You can hear me, right?
Yes, from my side,
Perfect.
absolutely.
Thank
Thank
you.
you.
My apologies. Not sure quite what happened. I'm glad the gentleman from Orion was able to switch at short notice. I'm Karthik. I'm the CTO at SIONIC Energy. SIONIC is a company in Rochester, New York. And I'm hoping to walk you along on the road to commercializing 100% graphite-free silicon batteries, silicon anode batteries. I'll walk you through a little bit of a background and history. We'll talk a little bit about some of the challenges of silicon. Most of you are aware there was a very nice presentation by GDI, Rob, a good friend of ours, yesterday. So that would simplify some of my work. And I'll walk you through some of the holistic approaches we've taken towards anode design, electrolyte design, SCI engineering, which affects the performance and the safety, and ultimately end up with the cell design and the performance that we are able to develop and generate and perform and demonstrate pretty significant energy densities and performance. I will wrap the talk up with some of our next steps and what we are in the midst of doing at the moment with regard to cylindrical cell development as well as scaling our electrode process as well as our cell manufacturing. So SIONIC is all about doing silicon right. We have been leveraging about a decade of electrolyte and advanced additive development with our battery technology and battery development expertise to really try and unleash the full potential of silicon. And so we've chosen to go with 100% silicon, whether it's silicon carbon, whether it's pure silicon, metallic silicon, micron silicon, etc. The goal of reducing cost and providing unmatched performance for the industry. As a startup, you have to differentiate yourselves, as most of you know. You cannot have a Me Too product. You cannot be a Me Too company. There's enough companies out there developing all of these technologies, and so this is the path we've chosen. And hopefully I'll walk you through that and demonstrate what we've been able to do. So SIONIC today is a battery company, battery technology company. We are our business model is one of technology development and licensing. We don't intend to be a battery manufacturer. But again, as most startups realize, just having technology is not adequate. You have to demonstrate it in practical, test vehicles to convince others that what you have is certainly something that's worth going after. The history of the company is that we started about 10 years ago as GNOMES Technologies, which was almost entirely focused on electrolytes. So electrolyte additives, electrolyte development for lithium batteries has been in our DNA for about a decade. As I mentioned, we are located in Kodak Industrial Park, Rochester, New York. About 25 scientists and engineers, state-of-the-art labs with tremendous amount of test channels, cycling capabilities, abuse testing capabilities, as well as analytical tools like DSC, TGA, ARC in our own facility. We're also very close to Rochester Institute of Technology, where we utilize a lot of their capabilities like SEM, NMR, as well as the battery prototyping, which is where we do our electrodes and cell assembly. So the silicon is obviously very, very attractive due to the significantly higher energy densities and capacity of the silicon, 10x that of graphite. But as we all know, there are serious challenges with silicon, but that's what makes it more exciting. Now, I'm not going to go through every little detail of these charts, but suffice it to know, obviously, that there's significant material level challenges with silicon, expansion and contraction, disintegration of the structure, particle breakage, etc. This then manifests itself as a problem at the electrode level, a much more macroscopic level, where you have shifting of the particles, destruction of the conductive network, compromising the adhesion to the copper collector, etc., etc.